Nature is full of wonder. It paints with vibrant colors, it sculpts amazing shapes. We hear its songs in the wind and waves, but there is more than meets the eye. Hidden within this breathtaking beauty is a code, a secret language of structure and order. This structure is often mathematical. It's a quiet organization beneath the apparent wildness. We just need to learn how to see it clearly. The world whispers its profound secrets in numbers and patterns. Think about the world that surrounds you every day. A dense forest with towering trees, a sandy beach stretching to the ocean, even your own small garden at home. Patterns are absolutely everywhere you look. They repeat themselves consistently. They organize the elements of nature. These are not mere accidents or random occurrences. They are intricate designs carefully laid out. Nature uses surprisingly simple rules. These simple rules create complex and stunning beauty. Mathematics is the essential key to understanding these fundamental rules. It's like discovering a hidden map to nature's grand designs. One of these secret codes is a special list of numbers. It begins very simply with 0, then 1. To get the next number, you just add the last two numbers together. So 1 plus 0 equals 1, then 1 plus 1 equals 2. After that, 1 plus 2 equals 3, and then 2 plus 3 equals 5. This important list of numbers continues onward. 0, 1, 1, 2, 3, 5, 8, 13, 21, and so on. This is famously known as the Fibonacci sequence. It is a very simple idea to grasp, but it appears in many truly surprising and fascinating places throughout the natural world. This sequence is not just a string of numbers on a page, it is much more than that. It is a blueprint. Nature uses this blueprint extensively. You can observe it in the way that living things grow and develop. Think of a tiny seed just beginning to sprout from the soil, or picture the delicate petals of a flower slowly unfolding to the sun. The Fibonacci numbers often describe the precise arrangement of these parts. This mathematical arrangement helps plants to grow strong. It helps them to be efficient in their use of space and resources. It's a fundamental building block of life. Look very closely at a common pine cone. You will certainly see spirals in its scales. Some of these spirals will curve in one direction, other spirals will curve in the opposite direction. Take a moment and carefully count these spirals. You will often find Fibonacci numbers when you do so. Perhaps there are 8 distinct spirals going in one direction, and then you might count 13 spirals in the other. These numbers, 8 and 13, are neighbors in our special sequence. This is not a mere coincidence at all. It is a clear example of nature's inherent design at work. Sunflowers provide another truly amazing example of this phenomenon. Their large heads are densely packed with hundreds of seeds. These seeds also form very clear spiral patterns. Again, if you count them, the numbers will be familiar. You might discover 34 spirals turning one way across the head, and then you could find 55 spirals turning the other way. Sometimes even larger pairs of Fibonacci numbers appear. This particular arrangement is incredibly clever. It allows the sunflower to pack the maximum number of seeds. Absolutely no space is wasted in this design. Every single seed gets access to sunlight. The magic of these numbers does not stop with pine cones and sunflowers. Artichokes display these recognizable spirals in their leaves too. You can also see them in the scales of a pineapple. Many different types of flowers have a Fibonacci number of petals. For instance, lilies often have 3 petals. Buttercups commonly have 5 petals. Daisies might have 34, 55, or even as many as 89 petals. These numbers are not just for show, they create beauty. They also play a crucial role in helping the plant thrive. It is a fundamental pattern of life itself. Why does nature seem to love these specific numbers so much? It is really all about achieving maximum efficiency. It is also about creating structural strength. This spiral arrangement, guided by Fibonacci numbers, helps plants get sunlight. It aids them in collecting vital rainwater effectively. It makes them more stable and robust as they grow taller. The Fibonacci sequence provides an optimal solution to these challenges. It's a remarkably simple mathematical rule for nature to follow. But this simple rule creates complex and nearly perfect forms. Nature, it seems, is a great and subtle mathematician. Now, let's explore another fascinating kind of math in nature. Imagine a shape. This is a special kind of shape that repeats itself. It repeats over and over again at smaller and smaller scales. This is the fundamental idea behind a fractal. Think of a rugged coastline as it appears on a map. It looks jagged and irregular from a distance. Now, zoom in closer on a section of it. It still looks just as jagged and complex. Zoom in even more to a tiny piece. The intricate, jagged pattern continues to appear. This is a classic fractal pattern. Nature is absolutely full of them. Coastlines are a very classic example of natural fractals. From a great distance, perhaps from an airplane, you see big bays and prominent points of land. As you get closer, you observe that those points have smaller wiggles and indentations. Get closer still, and you will see that tiny rocks and even individual grains of sand often make similar repeating patterns. The overall shape exhibits what is called self-similarity. This means it looks like itself at many different sizes or scales. This incredible complexity actually comes from very simple rules being repeated many times. It's an endless, fascinating level of detail. Look carefully at a tree. Any tree will do. A big, strong trunk grows large branches. Those large branches then grow smaller branches from them, and those smaller branches, in turn, grow even smaller twigs. Each part, like a branch or a twig, looks a bit like the whole tree in miniature. This is a clear example of a fractal structure in the plant kingdom. Ferns are another beautiful and very clear example. Each large frond of a fern is made up of smaller fronds, and those smaller fronds are often made of even tinier versions of themselves. It is a pattern of infinite regression, a beautiful repeating echo. Even delicate snowflakes often show fractal qualities in their design. Their intricate six-fold arms have smaller branches growing from them. These smaller branches frequently mimic the design of the larger arm. Broccoli is a common fractal that you can actually eat. Each small floret looks like a tiny, perfect version of the whole head. You can see this pattern easily. Mountains, winding river systems, and even bolts of lightning can show fractal patterns. Nature uses this repeating design strategy extensively. It builds great complexity from underlying simplicity. It's a very efficient way to fill space or distribute energy. There's another important mathematical idea that we can see. It is present almost everywhere you look in nature. This widespread concept is called symmetry. Symmetry essentially means balance. It means that one side of an object mirrors the other side, or it can mean that parts are arranged equally around a central point. Think for a moment about your own body. You have two arms and you have two legs. One side of your body is very much like the other side. This common type of balance is called bilateral symmetry. It is very common in the animal kingdom. Snowflakes are justly famous for their exquisite symmetry. Each individual snowflake is completely unique in its fine details. Yet, despite this uniqueness, they all share a common structure. They all have 6 sides, or 6 points, creating a hexagonal pattern. They clearly show what is called radial symmetry. This means they look the same if you turn them around their central point. This beautiful, perfectly ordered structure forms from tiny water molecules. These molecules freeze in the cold air as they fall. Each intricate arm balances the others perfectly, a tiny frozen jewel of mathematical precision. Many flowers also possess radial symmetry, similar to snowflakes. Think of a cheerful daisy or a vibrant sea anemone. Their petals or tentacles spread out evenly from the center. They radiate outwards like the spokes on a bicycle wheel. Butterflies and many other animals exhibit bilateral symmetry. This side-to-side balance helps them to move effectively. It helps them to fly straight or swim with purpose. Symmetry is not just visually beautiful to us, it is also very practical and beneficial for the process of life and survival in the natural world. So it becomes clear that nature is absolutely full of math. It's there in the elegant spirals of a seashell. It is evident in the branching patterns of a mighty tree. It is captured in the delicate, fleeting design of a single snowflake. Math is like a secret code, a hidden language. It helps us to understand how nature truly works. It shows us the underlying order and profound beauty in the world. These mathematical patterns are everywhere we look. They are just waiting for us to notice them. Math truly is a universal language, and nature speaks it fluently and with great beauty.